In this video, we are going to go over slope-intercept form, and we're going to see how that applies to a linear function. So a linear function is in the form of f of x equals m times x plus b. And you might recognize this as slope-intercept form. If you remember from Algebra 1, slope-intercept form is y equals mx plus b, where m is the slope of the line and b is the y-intercept. So you can see that a linear function is a combination of multiplication and addition, or if the y-intercept was negative, it would be multiplication and subtraction. In the next video, we're going to review slope, but for now, let's go over the y-intercept, and we'll also talk about an x-intercept. So the y-intercept is the point or coordinate at which the equation intersects the y-axis. That is the y-intercept. So remember that y-intercept crosses the y-axis. And that's your vertical axis. And the x-intercept is the point or coordinate at which the equation intersects the x-axis. So that would be your horizontal axis. So if I was to draw a line, the y-intercept would be at this point where the equation crosses the y-axis, and the x-intercept would be at this point where the equation crosses the x-axis. But for slope-intercept form, we're only concerned about the y-intercept. So let's look at an example of this. The equation that I'm going to give you is y equals 2x minus 4. This is in slope-intercept form, and we are also able to write this as a linear function. Let's practice graphing functions. So let's go ahead and change this to a function. Using function notation, instead of y, we're going to say f of x equals 2x minus 4. So from slope-intercept form, we know that our m, or our slope, is positive 2, and we know our b, or our y-intercept, is negative 4, because this is minus 4, which is the same as adding a negative. Let's go ahead and do a t-table and then graph this. We're going to use the values 0, 1, and 2 for x. So when x is 0, f of 0 is equal to 2 times 0 minus 4. When x is 1, f of 1 is equal to 2 times 1 minus 4. When x is 2, f of 2 is equal to 2 times 2 minus 4. 2 times 0 minus 4 gives us negative 4. 2 times 1 gives us the negative 2. And 2 times 2, which is 4, minus 4 gives us 0. Here's our coordinate system. We have our x-axis and our y-axis. And we're going to graph the following points. When x is 0, f of x is negative 4. So x is 0. Go down if each of these are 1 unit. 1, 2, 3, 4. Here's the point 0, negative 4. Our next point is 1, negative 2. So 1 in the x and negative 2 in the y, or the f of x. And then when x is 2, f of 2 is 0. So over 2 in the x and 0 in the y. Let's go ahead and connect the coordinates since we know this is a linear equation. So now let's look at the parts of this line. We have our slope, which we can go over in our next video, but let's look at our y-intercept. We said our y-intercept would occur at -4. So when our equation, or our line, intersects the y-axis, that's going to be at the point -4. And you can see that we even have that as our first point. When x is 0, that means that we're on the y-axis. And that occurred at -4. So you can see our y-intercept of -4 did indeed occur at the point 0, -4. So if our y-intercept occurs when x is equal to 0, our x-intercept, when it crosses the x-axis, will occur when y is equal to 0. So when y equaled 0, or f of x in this case was 0, we had that x was equal to a value of 2. And you can see, indeed, that when our equation crosses the x-axis, 2 is the x-intercept. So when graphing an equation using slope-intercept form, you already have a point without even doing a t-table when you look at the y-intercept. Right away, we know the y-intercept occurs when x is 0, and we're given that y value of -4. So you could automatically plot 0, -4 on your graph. And like I said earlier, in the next video, we're going to go over slope.